All right, this is chapter 4. It's about sniffers. We're going to talk about a few of them in more detail than the rest. So we're not going to talk about all of them in detail. Okay, sniffers, basically listening in on traffic. There's lots of them out there. Cane, Wireshark is, or used to be known as Ethereal, is the most popular. Okay, they're nearly impossible to detect, but there are ways of doing it, and we'll talk about some of those. Okay, they could be bundled, they could be free, they could be commercial. There's just lots of them out there. Okay, we'll talk about some of them. Okay, they come with Windows. Network monitor that comes with Windows is actually the crippled version of SMS. I never played with that one. It's a decent sniffer. It just doesn't give you that much capability. Okay, TCP dump is free. You can just get WinDump or TCP dump and run that. Snoop's available. There's just all kinds of different ones out there. We're going to look at a few of them. Okay, we're actually going to look at TCP dump. Okay. All right. So TCP dump's got a lot of capabilities with it, and we're going to look at a couple of them here. But it's so nice. You can say like TCP dump port 80, and it'll instantly just capture port 80 traffic. So it's kind of nice. Okay. It's all kinds, and you can also tell it to write to a file. You can also use it to replay files, which is nice as well. So I'm going to demo TCP dump for you.
So you'll what? TCP dump port 80.
Yeah. Just port 80. Hit enter. And it'll just.
Well, right. But if you want to write what you found.
Right. Exactly. Now, I might not have been clear, like Jimmy wasn't clear on this originally, but if you're in multiple classes, you'll have multiple legs inside of the vSphere system. If you want to use my backtrack, you all have one, but like I was telling him also, in this class in forensics, I don't really give great answers sometimes, because I find, like, for instance, backtrack.
It's a challenge.
I'm assuming some of you have used it before, but some of you probably have not. And in the past, people say, what's the password for backtrack? And I tell them it's Tor. But then they forget it. But if I tell people, go figure it out yourself, they're much apt to remember it because they had to figure out what it was. So, but this one we're going to use backtrack. And I got my machine. I already started it. I didn't log in yet.
Hey, Ken.
Yes.
Are you recording this?
Yes, I am. Okay, this is my backtrack machine. Well, the resolution is going to suck, but it's okay. It comes up with a login screen. Now, the login for backtrack, I mean, if you go on Google and type backtrack login, it just tells you. It's there. Okay? It is root, and then root backwards is the password. Then you come up to a command prompt. You're in backtrack. You can run a lot of stuff from here. Like, I know it's going to be hard for you all to see, but you can watch the recording. Like, I could type TCP dump, port. Let's just do TCP dump. Yeah, just nothing. It's going to show my traffic. Okay. This is the traffic on my network card right now. Okay. But I'm going to stop it. I'm going to go. And you can also hit the up arrow to bring back the previous command you type. I can go port 80. So why am I not seeing anything?
Because
You have no web traffic.
I have no web traffic going on. And I'm not doing anything on the machine. So you can't. I used to run an ISP, which some of you know, and a couple of my clients ran chat servers. And sometimes I'd have to make sure they were working correctly. And they work on port 6666 or 6667, a couple different ports. So the way I could tell if they were actually working, I was just bring up TCP dump and the port number just like that, and I could just see that traffic. It's a real quick and easy way to do it. You can, send it to a file. You can do whatever you want with it. All right. Now I'm going to stop that for a second. Now, in backtrack, it's a command prompt, obviously. If you don't know what to do, like I could type TCP dump. Some places you can do -- help. I think this one will allow it. No, it won't. Where's -h on this one? Okay.
is it just one dash?
No, I thought this one supported it.
Oh, it's question marks,
Oh.
isn't it?
No, well, I know you can type man TCP dump, and it'll show you everything. Okay. If you type man MAN space TCP dump, it's the manual page. Shows you all about it. It'll show you all the different commands, and you can. Well, if my window was the right size, I could scroll up and. Well. Okay, yeah, there it is. There's all the commands. So you can go through here and see all the different commands to use it with. So it's really a cool little program. Okay. And it goes on. You can actually specify individual flags, individual components of a packet. You can specify anything with it. It's a really nice tool. And we want to do, no, it's Q, isn't it? Yeah, Q. And to get out is Q. To stop it, the reason is it uses VI as the editor. VI is the visual editor. What's VI stand for? No, not visual editor. Whatever it stands for, that's what it is. And the commands in there are weird. But once you know them, like Q to quit, you know, W to write, that kind of stuff. Okay, so but again, this is the command line. If you want to look at the GUI version, like Wireshark, I'm going to run that real quick. If I try to run Wireshark in here, it says, can't do it. Okay, but I can always start X. If you type start X, all one word, it starts the GUI, the graphical interface for Backtrack. Yeah, for Backtrack. All Backtrack is a big old collection of tools. That's all it is. Okay. Then you can go in here if you want. You can actually bring up the command prompt again, or the terminal window. Now I can type Wireshark, and it'll come right up and load. Okay. Yes, sir.
Whenever I was doing the assignment with all the different tools, one thing I noticed was set.
Right. Social engineering
toolkit. Yeah. It was looking for the Metasploit Framework 3, which wasn't actually there, so I had to go.
Oh, you had to install it. Yeah, it's not on
I had to
there
pull it
yet.
down from the GitHub and all that.
Okay.
But, I think it doesn't do it if you just do it on base install, but I had actually upgraded my Backtrack install and everything.
Okay. Yeah, we'll be playing it, not today, we'll be playing with that. But so we're going to look more at this stuff here in a little bit. Okay. But, so everybody okay on kind of what TCP dump is? It's a really nice tool for capturing traffic. You can replay traffic, you can do all kinds of stuff. No, it's TCP replay to replay traffic. But you can capture. Okay, there's some commercial ones out there. They're very expensive, but they're good. Like LandGuard is not really a sniffer. It's kind of like the commercial version of Nmap, and it works really good. Not Nmap, Nessus. It works really good. But there's just a bunch of different ones out there. Free sniffers, obviously they're free. Is free always great? Not necessarily. You get what you pay for sometimes. But like Wireshark, you can see is really good. TCP dump's free. You know, Backtrack itself's free. Okay? What do? Okay? They basically turn on your network card and listen. Okay? It's pretty much what they do. They look at the traffic passing through it. Normally a network card receives all the traffic on the network, on your segment of the network. And then if it's destined for it, it reads it, does stuff with it. Normally, it just dumps it if it's not destined for it. Sniffers, what they do is they force your computer into promiscuous mode, then they receive all traffic. Okay? You can read anything on your segment. Now, what if I wanted to read all the traffic in this building? Anybody know how I could do that? Huh? Wireshark. If I ran Wireshark on this machine, I'd only read the traffic
In this.
on this segment.
Right.
Right.
This subnet.
You need like a hub or port mirroring or something. Like Chapel Supply, one of my old clients, I need to capture their traffic to see what's going on in their network. I would put hub out there. I just, between, their router and the cable modem, I just put a hub in there. So, a hub is, the difference between a hub and a switch, if you don't know, a hub is like an extension cord. Just broadcast it to everybody. A switch segments it out. You only get the traffic destined for you, so that's why they're faster and they're a lot better. But it's not always the best thing when you want to do stuff like this, okay? Obviously, you need a network card to run a sniffer. You need some sort of driver. WinPCAP is what Wireshark uses. I'm pretty sure it's WinPCAP, isn't it?
Yep.
Yeah, WinPCAP, okay? Then you need some sort of buffer to handle it. I actually had to write a Java version of Snort when I was in the University of Tulsa. And I was capturing the traffic, analyzing it, and then reporting on it. That's what we had to do. I wrote my program pretty quickly. I got it working, but I was only getting a small portion of the data. Does anybody know why?
Because you were on a switch network.
Well, the stuff I was trying to capture was on my segment, so I would have captured it. Well, the problem was I was reading traffic, analyzing it, reporting on it. While I was analyzing and reporting, what was happening to traffic on the network? It was passing me by. I wasn't capturing it into a buffer. So I basically had to rewrite my program to be a threaded program that had one thread, all it did was capture traffic, just non-stop. Then another thread analyzed it, and the third thread reported on it. So you needed a buffer for that. All right. So we have a network card with some traffic. We have our driver and a buffer and something to decode it, analyze it, and we're going to see a whole bunch of that here in a little bit. Okay. All right. The buffer is where it stores it in memory. Okay. Decoder takes that hexadecimal data and does something with it. Okay. I do have a Java program to do all this. If anyone wants to get a copy of it, haven't used it in a few years, but I still have it. If you just want to see what one looks like, then you want to be able to analyze the packets. Okay. Here's what TCP dump looked like. We looked at that a minute ago on the screen. Okay. Where should we put the sniffer? Again, if I wanted to capture everything in this building, probably wouldn't be a good idea to put it on this machine. I probably want to put it, somewhere where this building connects to the outside world. If I want to connect in, like maybe everything in one room, then I could be in a different location for that. Okay. Normally, you put them on computers or connections or wherever you think you want them. Okay. All right, here's some examples. Could have one outside the firewall. Anyone have a cable modem? Try putting a hub or capturing traffic on the outside of your cable modem. It's amazing the amount of traffic you get out there because cable modems are shared. I don't know if you realize that. You'll see all the ARP traffic for your whole entire neighborhood be coming through there. And it's a lot of stuff. Okay, but it really depends on where you want to do it. Obviously, in this network here, we have a DMZ, which is the demilitarized zone. So some of the traffic from the internet's coming through and going to the web server and the mail server. That's probably a good place to put something so I can see what's happening in that area. Okay? So you can put it wherever you want it. I could have one, in the county area. And I could have one wherever. So, okay. All right, media access control address, the MAC address. We're going to look at those. Every network card has one. I don't know if you realize that, but they do. They're all different. There is a chance you could actually have duplicate NIC cards. Addresses, because there's only so many numbers out there, and you can't change them sometimes. When I was at Tulsa, they were trying to break into this one system. It was kind of like a little game they were doing, and after 10 attempts, they would block you. They would cut you off. Well, they would keep track by MAC address. So what this guy did is he wrote it, do 10 attempts, he changed his MAC address, get another IP address, 10 more attempts. Change his MAC address, get another IP address, and it went on forever. So the guy was pretty good. Okay, let's look at ARP real quick. Yeah, let me show you what ARP does. And that isn't. Actually, I can show you ARP on this machine, I think. Okay. ARP, Address Resolution Protocol. I can even make this one look a little bigger. Let's go 24. Okay. So with ARP, it'll resolve chunk in my throat. IP address to MAC addresses. So if I go ARP-A, what it does is it shows me my ARP table. It's showing you the addresses that I have resolved. Okay. Obviously, I got a lot of IP addresses and quite a few MAC addresses. You can see the broadcast address is the one with all the Fs. You can see my gateway, which is the top one. These are the machines I've talked to. The ARP table keeps its addresses for between 2 and 10 minutes, depending on if they're used a lot. If they're used frequently, they'll stay in there longer. If they're used just once, it'll only stay there for 2 minutes. Okay. Now I can do something like ping bs-131-01. That's my office. Now if I run ARP again, I should have a new entry. Oh, what is my? Oh, hold on. 60203.2. Okay, so it's not in there. My machine in my office is 10.60.203.2. Okay, I did that with a command called nslookup, name server lookup, and I got my IP address. Okay, why isn't that IP address on the list? Anybody?
You haven't actually connected to it. You just set
Oh, I did.
to it.
Cool.
Okay.
Well, you got a response back.
Yeah, I'm talking to her all day long. Anybody? Well, what do you see on this list? What's in this list? What numbers do you see?
Are those room numbers?
Those are room.
Subnet,
What now?
the .50 subnet.
When the .50 subnet. My address is 10.60. a different subnet. And ARP only handles broadcast. This building actually has 2 different subnets in it, 1050 and 1060. So what's happening was, when I tried to ping my office machine, my machine here said, oh, wait a minute, you're pinging someone on a different subnet, so it didn't even try to contact me. It went straight to the gateway. So then it sent it to the gateway, then the gateway forwarded it onto my machine. The gateway just happens to be a switch upstairs. So, yeah, I don't know if I can find another room. Let's try 2. Okay, how about 3? Ah, Roy's on. Okay. Roy is 200.30. See how it was not on the list before? 200.30 is not on the list at the top. Now if I do this again, 200.30 is now on the list. Because I contacted him, and I'm going to remember it for a while. I'll remember it for 2 minutes. If I keep doing it, I'll remember it for longer. So the ARP just builds a list of whom connected. Do you see any problems with this?
You can intercept.
Yeah, it can be intercepted. I mean, you could actually spoof this information, put false information out there. Because ICANE has something called a man-in-the-middle attack, where I can basically, the problem with the ARP protocol is it's very trusting. There's a name for it, which I cannot remember. But it's very trusting. If I was to tell Daniel that my name is Bill Gates, he'd be like, cool, Bill, nice to meet you. That's what the ARP does. If you tell this is my MAC address or my IP, it's like, okay, cool, nice to meet you. It believes everything you tell it. So that's why it's vulnerable, okay? So there's an example of ARP. Okay, transferring data. You could be on the same network where they just have to go computer to computer, but it could go through routers, could go through all kinds of different ways. Okay, majority of the time you're going through a bunch of routers to get there. Okay, they first examine the IP address. Everybody know what an IP address is? Hopefully we know what that is. That the numbers with periods between them or colons, depending on which way you're doing it. For the homework, by the way, I need periods, but we'll get there in a minute. Okay. It looks up the IP address. It's kind of like the Postal Service trying to figure out. It goes by zip code first. Y'all see we're not getting mail on Saturdays anymore starting in August?
What?
And starting in August, there's no more mail delivery on Saturday.
Oh.
Who actually gets mail anyway?
Junk mail.
I look at it. It's usually junk or, yeah, it's junk. So, all right. So it says Alice has information about the first router and the IP address to Bob's PC. It says Alice's computer employs an Ethernet frame to communicate with its router. Then that router goes to the next router and so on and so forth, so it gets where it's going. Okay. Routing tables are updated depending on which protocol to use, RIP or RIP2 or OSPF. I'm pretty. Isn't RIP the most popular right now? Does anyone know?
Yeah.
Yeah.
It's most common.
Yeah.
In most of the protocols used in other, not just Cisco, but like multiple different vendors.
So yeah, it's that's a whole nother class, but yeah, RIP is the most common there. So we, the packet could literally go from wherever. Okay? I can't show you how a packet gets there from here because they block our pings. But it could, like from here to Choctaw, it could literally be going through Dallas. Because maybe that's where Rose State connects it. It really depends on where it gets to the backbone and goes from there. Okay. All right, and the frame, we'll actually be looking at this here in a minute. The frame is broken up into different components. Okay, it has addressing, it has length, it has some bytes, it has a CRC, which we're going to look at all that stuff here in a minute. Okay. Now they talk about TCP/IP. TCP/IP is a protocol suite, they call it, because it's a bunch of protocols all put together, and it's got a frame. Again, we'll look at that in a minute when we bring up Ethereal or Ethereal or Wireshark or whatever you want to call it today.
Ethereal was just the previous name to Wireshark.
Right,
They had
yeah,
to
the
change
same
it
one.
because-
They had to change it because the guy who originally developed it said you can't use it or some weird thing. I don't know what it is, but okay. All right. So they keep adding components onto this. Think of it like you got an egg. Then the egg is put in a carton, and the carton is put in a bag, and the bag is put in your car. Okay. Got all that information on it, and we're going to, again, look at all that stuff. The data is sent along as well, and also a CRC cyclic redundancy check is used to look for errors. They do a mathematical calculation on the data, come up with a value, attach it to it. When it gets to the other end, they do the same mathematical calculation. If the number matches, it's good. Does that guarantee positively it's good? No, but it's pretty darn close. That's what we use. Okay? It says the frame is then, once all this stuff, like I said, the egg is all put together. It's sent across the cabling, or Ethernet, or whatever we're using, or wireless, or whatever, and sent off to where it's going. Then when it gets to the other end, it's actually torn apart. The packets continue around the network, and if it's destined for my machine, it gets interpreted by my machine, and then we do something with it. Okay? But to make it so our machine, which we're going to use in Wireshark command, can listen to everything, we put it in what's called promiscuous mode. It says the NIC can retrieve any data transmitted on the network segment. Now what sucks is, since we have a switched network here, the moment my machine came on this morning, it told the switch what my address was. So our switch upstairs is only sending data on my segment destined for my computer, which is really a good thing. It means we're not having all this extra data going everywhere. But we still get some broadcasts and stuff like that. But before switches, when we had hubs, everybody got a copy of everything. So, cuts down on all kinds of stuff, okay? It says a sniffer on any node of the network can record all the data that travels on that node, okay? It says it puts in promiscuous mode what we've talked about, and they can bypass TCP/IP and receive everything, okay? There's what, and that's a real old picture of Wireshark. Just showing you an example of what they look like, okay? And we're gonna look at some of them, okay? All right, you can use them for monitoring, you can use them for looking for errors, and we've used it quite a bit. I've used it in projects and all kinds of stuff, okay? This is partially functional sniffers that falling out of favor because they do a lot now. In Ethereal or Wireshark, we're gonna look at this now, okay? And I'm gonna bring all this up. I'm gonna show it to you, all right. I'm gonna bring it up inside of Backtrack, okay? Here we are, we're in Backtrack. Now, once I got Wireshark up and running, you need to go to Capture Interfaces. And the first thing you'll see, there you go, is some packets. Wow, we had one. Come on. Oh, there we go, a couple more. You always want to pick the interface that has traffic on it. Okay? Because sometimes, depending on your machine, you might have a couple other interfaces on there. So we're going to pick the top one, and we're going to hit Start. Okay? And now we're going to be retrieving some data. So we're seeing some ARP packets, some IGMP packets, some broadcast packets. We're going to see all kinds of stuff. Let's just stop it real quick and look at something. Okay, I'm going to stop it. I'm going to pick an ARP packet here. Okay? I'm actually going to pick one a little bit farther up. There we go. I'll pick this ARP packet because it's in the middle. Now, with this tool, it's kind of cool. You can slide this thing up at the bottom. You see the 3 different sections down there? You can expand these out. You can see the ARP protocol, the Ethernet 2, and the frame. We're going to talk about each one of these in detail. Okay? Let's start with the frame first of all. I can see exactly how many bits were on my wire. 480 bits. Okay? I can see when it arrived. Okay, I can see the frame number. I can see it was 60 bytes or 480 bits. I can see some basic information about it. That's, you know, it's the packet itself. But it's not any of the addressing information, anything like that. The Ethernet 2 is now where we have the source and destination. So we have a source, and the destination is broadcast. What the heck does that mean? Well, let's look at our packet again real quick. I'm going to scroll over. What the packet info says is, who has 10.10.0.199 tell 10.10.40.168? What that means is somebody, whoever is 10.10.40.168, is sending a broadcast out to everybody. They're saying, hey, who has address 10.10.0.199? Whoever has it, tell this guy. So if you look at the addressing down here in the bottom section, the source is 10.10.40.168 because he's the one asking the question. But the destination is all F's. It's broadcast. It's sending out to everybody. And the reason we received it on our segment is because it's a broadcast. It's kind of like at Walmart. Hey, the white car, you left your lights on. Okay? It's a broadcast that goes to everybody. It didn't go to a particular person. Okay? So we see the source, we see destination. Now, I'm going to, I'll get there in a minute. Okay. Down at the bottom, actually I'm going to make it so we can see more at the bottom, maybe. If I can find the right, there it is. Now, when I click on these things, like I click on destination, then I click on source. You see the highlighted stuff at the bottom? Everybody see that?
Yep.
Okay. that is the actual location in the actual hex data for the packet. Okay? Now, when I click on the type, it's an ARP packet. Comes from right there, 0806. What's happening is this protocol analyzer, Wireshark, is analyzing this data. These words up here, that's Wireshark putting it all together for you. See, I had to write a program that took this stuff and made this stuff. Okay? It's not that hard to do. You just figure out what the frames look like. They're not that difficult. Okay? But those bits right there, 08 and 06, means that it's a ARP packet. If it was something else, it would have a different number there. Okay? I'm actually going to pick on a different packet. So remember, we're right there. We're at the these 2 bits. I'm going to pick a different packet real quick. And it's these same 2 bits, remember? But they're not 0806 anymore. Now we're 86DD, which is an IPv6 packet. Let me go back to ARP again. See how they change? Now we're 0806 again. Everybody with me? So I asked you what type of packet it was. What's the answer? ARP packet or 0806 packet. Okay. Either one's acceptable there. Okay. Now, also I'm going to click now at the actual ARP request itself. Okay. Comes down here, tells me what protocol it's using IP. Okay. It's telling me the MAC address. It's telling me the sender's IP address. It's telling me all kinds of stuff. There's the target IP address, who they're looking for. So ARP's got quite a bit. Now I'm going to record some more traffic. Interfaces, start, go. Continue without saving. Now I'm going to actually do something here. So I'm going to bring up some a web page. Okay, is it coming? All right. Now I'm going to hit stop. All right, that web page loaded. Now you see a bunch of other type of traffic. You see a lot of green traffic. That's the actual web page itself that loaded. Okay, all this green stuff. Now when I click on these packets, they're a little bit different. Okay. Now remember, before we had the frame, then we had Ethernet 2, then we had ARP. Those were the only 3 sections we had at the bottom. Okay. For this assignment, I give you this stuff right here, the hex only. You have to figure out what it means. Okay. It's not difficult. It's easy. Easy, easy. Okay. Let's look at the frame of this packet. Again, it's a different packet type. And you all got Wireshark. Start Wireshark and look for a packet that has the same numbers in it, or same layout, and you can figure out what they mean. Okay. All right. So the frame, same basic stuff: the date and time, the length, and all that stuff. So the frame, not that critical on here. And now Ethernet 2, we got our source. Now, this thing says VMware, and this one says Cisco. How does it possibly know that? Where did it get Cisco from? From the MAC address. The MAC addresses, certain vendors has specific MAC addresses. So this thing knows that, hey, this came from a Cisco. It's just Wireshark being nice for us and solving some of these answers for us already. Okay? So we can see the MAC address it came from. We can see the destination. Okay? We can see that it's a IP packet. And let's see. Now we can go down to IP. Is this IPv4 or v6?
4.
IPv4, okay. We can see the header length. We can see the protocol. It's TCP number 6, and that's where it came from. Remember, the other one, the ARP packet was up here. But this one's still there, but it's IP. It's not the exact same thing, okay? See, there's the type, but under the IP area, the protocol is TCP. That's why it's TCP IP, okay? Time to live is 64. What time to live is, when packets are sent out on the internet, they are given a TTL date, time to live. They range, most of them are normally starting off at 64 nowadays. It really depends on your hardware. That can go up to, I think it's 128. Every time it goes through a router, it decrements by 1. Say I'm trying to send a packet from here to Tulsa. Every router goes through, that number is going to get decremented. You should be able to get anywhere in the world anyway in 30 hops anyway. But they do that, so every time it goes through, when it gets decremented, that way if a packet gets lost somewhere, Sooner or later, it's going to reach 0, and then it's going to be deleted. You wouldn't want the packet to just keep going forever. And that starting value is actually hardware. I know different vendors have different numbers. Okay, so there's our TTL, there's our protocol. Now I want to look at. Whoa, okay. I'm on time delay. Everybody see that? What's the time delay number? Are you sure?
Decimal.
It's 64 decimal. But down here, we're in hex. So see this down here? Don't tell me the TTL is 40. It ain't 40. 40 is 40 hex, which is 64 decimal. If you don't, let me show you how to convert it. If you don't know how to do that. Oh. Am I in the wrong machine?
Hit the wrong calculator.
Yeah.
I want this one.
You hit the.
Did I do it again?
You got to do the second one when you do a calculator.
What now? Oh, where did that calculator come from?
Actually, it comes from Hex Workshop.
Yeah.
Oh, okay.
That's the X
All right.
calculator.
So down here, okay, well, we saw what we were working with. We were working with TTL. Okay, so we see 64 and 40. So decimal 64. If I click on hex, it's 40. Everybody see that? Very easily translates back and forth for us. Okay. So we see our TTL, we see our protocol. Let's look at this source address. So my source is 10.10.40.129. Everybody see that? But down here it says 0A082881. What the heck? So since I got this on hex, I'm going to type in 0A. Convert that to decimal. Oh, I get a 10. So everybody see the number? I want the answer in decimal, unless I specify differently. It's too easy if I ask for hex. I'm giving you the hex. Everybody understand that part? Ever hear that recording? Okay. I want the answer in decimal, just like Wireshark. Okay? So, there's our source address, there's our destination address, and these are always the same. See the location down in the hex? They're always the same position. Okay, now I'm going to select a different packet. Okay, there's our source. I'm going to select a different packet. Go down to source. It's in the same location. Okay, here's a different packet. We'll get down to source. Same location. So it's always in the same location. So if you see a TCP packet, now if you get over here and find out it's TCP based on the 80, I mean IP, and then is it this one for, yep, TCP. I mean, if you can match up those two and that one, then you know you got a TCP packet. Then all you got to do is go over here and say, oh, then I know the source is going to be right there. Destination is going to be right there. So look, bring up Wireshark, capture a couple different types of traffic, and then just look at them. Okay? All right, so that was our IP portion. So what this was our addressing. Okay, you know, TCP/IP is two different protocols. IP is like taking your envelope and addressing it correctly. But just by me addressing, does it really mean it's going to get there? No. TCP/IP is a connection-oriented protocol. IP is the connection-less portion of it. I call it idiot. I for idiot. So IP doesn't, I mean, just by me addressing an envelope correctly, does that mean it's going to get somewhere? No. The post office has to deliver it based on that address. So TCP is what makes it get there. Okay? The TCP is the next portion of it. Okay? Now we can see our ports. We have a source and destination. Okay? So it came from one port, went to a different port. Okay? I sent a request on port 80, so it got to that one on port 80. But I don't know if you realize or not, the web servers out there in the world, they don't reply on port 80. They only retrieve on port 80. So they reply back at a port greater than some number, whatever it is, 49,000 or something. So that's why the source is at a higher number. Okay? Here's our sequence number. Now the sequence number is kind of hard to understand. The sequence number is relative. It's not the actual sequence. So if you were to take this number, this 1445, and convert it to hex, it would not match. Because it's relative based on the packet, on the data streams. I don't think I put that one on there because it's a little hard to figure those out. Okay? But that's a relative sequence number. Okay? An acknowledgement number, there's flags. Here's some of the different flags, and you can look. And, you know, by clicking on this, you can see that I'm looking at the stuff at the very bottom. These two are the 50, and this one comes from the 10. Okay, and then there's the sin and the fin, and you know, you hear about synax, stuff like that. This was an acknowledgement flag because it came acknowledgements was set. Okay, you can see our window size. Talk more about that another day. And there's our checksum, our error checking information. Okay, validation's turned off. Okay, good. All right. Another thing you can also do in Wireshark, you can actually go up here and do follow TCP stream. And it'll actually reassemble that entire packet. It does that one stream of data. It puts all that together for you. And you could actually view it in hex. You can view it in whatever, and you can actually reassemble this data from this. All right. So this is actually a GET request, and it's a GET request for some graphic. You can even see it was a Mozilla 5.0 browser, Linux. So we're obviously talking about the one I'm using here. Okay, it's running Firefox version 10.02. There's the CSS, so there's all kinds of information on it. So what I did is I did follow TCP stream. And once you're done with that, you got to do clear it to see it all again. Everybody okay on kind of how to use this thing? You have an assignment just on this. I give you 2 packets. Now, in the Dropbox area and also in the content page, I put all the questions in there with the packets. But submit it in the quizzes area. It even says in there, submit in the quizzes area. But I did it there because there's really no time limit on it other than a week. That way you can at least see the questions and work on it on paper and then just submit your answers. That way it's automatically graded. Okay. All right, but it's the same kind of thing. I picked 2 packets. I give you this hex data at the bottom. You have to tell me, I ask you questions like, what's the source IP address? Now I ask you for MAC addresses. Colons or periods or nothing is fine between the letters. Actually, any one thing would work. I did a regular expression. So colons, periods, a space, or nothing would work fine. Don't put too many things between them. It'll cause it to screw up. Only said one thing, I think. Not possible. All right. Are we okay on what the assignment's going to be on this? Okay, let's continue on. Okay, that was Wireshark. Or Ethereal, or whatever the hell. I keep getting mixed up today. Okay, TCP. I already showed you TCP dump a little bit. There's a Windows version of it as well. It's free. Same thing. You can tell it to watch for specific traffic. You can tell it to capture a certain number of packets. You can tell it to capture a certain amount of traffic. There's all kinds of different things you can do with it. Okay. You can track network problems. You know, if you think someone's doing something they shouldn't be doing, then capture on a specific port or from a specific IP address. It's very easy. And the nice thing is it puts it in one little PCAP file. Then you can open up in Wireshark. So you could really use TCP dump monitoring Danny's network connection, and then we could very easily open that one capture packet up in Wireshark and only show me his traffic. So kind of nice. Okay. All right, here's another. So what was dash help? I thought I tried that. Didn't I?
Yeah, you did.
Oh well, maybe I typed it wrong. Who knows? All right, but it is kind of cool. There's an example of what it looks like. Yay, Snort. Another cool tool. It's probably the best IDS out there. You will not be doing an assignment on it, but I think you do in one of Eileen's classes. Okay, you can do all kinds of. This is what I had to write when I was in Tulsa. I had to write a Java version of this. I had to capture traffic and look on certain things. I had to look for different types of virus signatures and stuff like that. Okay, they work on pretty much anything. Okay, and there's an example of it, and I have it here. Okay, let me get out of Wireshark. Quit without saving. And we'll get out of here. Okay. Oh, hold on. Get my window back. I can go snort-x. And we're not going to do a project with it. At least not now. Isn't that -x? What? Swirl was -x. Okay, dash. Maybe it's -x. Okay, what's the darn command? I know it's dash dash X or dash X.
Well, some things the same as dash X down there.
Okay, show version number dash X. Dump the raw packet data. Yeah, that should be it.
Is that a capital A?
Yeah,
Should be lowercase maybe.
I think I did it both
You need to
ways.
do
Don't you need to specify the interface?
Oh, I think I do. ETH1. Hold on. No wait, no, I don't have to do it on this one. Do I have to? Let's see.
Should it be 01?
I think this one is. Now this one's the ETH1. I know. You know, I did this earlier today, and it worked.
Uh-huh. That's
We
what I
believe
would say
you, yeah.
too.
Hold on. Let's
I tried it earlier.
I did. Fine. Let's get out of here. System. Where's log out? Root. I want to get out of the GUI.
You just type start X again, don't you?
Yeah, but I don't need to do it. I can do it at the command line.
What is it? Control Alt.
Snort.
We need to pass through the function key to.
There. Well, no.
Remember that? And then
Well, that's what switching the different interface.
What the hell?
If you do that again, it'll take it back to it.
So you figure you want to get different users.
Why aren't you working?
Well, you could, if you do F1 again, it should take you back to
I swear, right there, it's a dash X.
Sudo it.
That's good.
It's the special X.
Yeah, let me get down so I can see my screen. Okay.
Listen on interface.
I hate this.
Yeah, dash I and then the interface, so
I shouldn't need dash I though, shouldn't I?
Snort options, filter options.
Snort dash I ETH1.
Okay, we'll try with dash I. Then make everybody happy.
Who? Yeah, Google might know.
No, Google does not know.
Google knows everything. Heresy.
See, it still didn't like it.
Maybe it's you. Doesn't like you.
We did this early today and it worked fine. Oh, What was the command to put it in promiscuous mode, Roy? Oh, he left. He was. I have config. It was ETH1 dash.
Permisc, I think. Yeah. And then you take it out as minus permisc.
No, that didn't do it. It's not in promiscuous mode yet. Oh, that's right. I did the minus. Okay, let's get it without the minus. Okay, now what I did was I put our network card in promiscuous mode. You can see right here in the middle, it shows promisc. Or up here it didn't. So now let me try snort again. Maybe it had to be in promiscuous to do it. I swear I could do just a dash X. Still don't like it. Well, we're not doing a project anyway. I don't know anyway, but it was working fine earlier. I don't know what the heck the deal is, but oh well. So much for that working right now. So I even did it on my desktop this afternoon. I don't get it. Okay. All right. Other network monitors out there. There's like the one that comes with Windows. There's SMS, which is the retail version of it. There's also HP OpenView, and there's tons of them. There's I think one called Big Daddy or Big Brother or something, and there's a whole bunch of them out there. They can do all kinds of different things. They can alert you. They can do all kinds of stuff. When I worked at Tinker, we were running HP OpenView, and they came to evaluate us, and they said, you have a security vulnerability. And we said, okay, what is that? Well, you have the ability to view the HP OpenView output. Like, yeah? And they were like, well, you shouldn't let anyone else see that. So I can understand what they're saying. They had it set up so we could see it in the LAN shop, but they didn't think that was secure enough. Because you can't see a lot of information. You can see uptime of machines. You can just see all kinds of information about it. All right, to detect them, there's a bunch of different tools to use, anti-sniff, sniff detect, and we'll just see a couple different ways. What you're really detecting is this right here. Is your network card in promiscuous mode? Okay. All right, DNS test, it says some of them do DNS lookup. So if the sniffer is doing a DNS lookup, an example is, what is it? Use it to view router traffic with, begins with W. Can't think of the name now. Great. But I would use it to download the data from my router to build charts over my router traffic. But it automatically did DNS lookups based on IP addresses. You know, we saw all those source and destination IP addresses. Well, some of these tools will automatically look those up for you and tell you, oh, this came from Dell, this came from wherever. So if they see an excessive amount of DNS lookups, that could mean you might have a sniffer running. Okay? So that's one way. Latency tests. It says several methods used to delay network latency to determine if there's a sniffer. Okay? Because it basically cuts it down. You're capturing all the packets. Okay? So you are one that just has a lot of traffic going to it. So you could possibly be a sniffer. A ping test. It says anti-ping can send a packet that contains a legitimate ping, but a fake MAC address where a normal machine wouldn't accept it because it's not correct. Okay? If it replies with a fake MAC, must mean it's in promiscuous mode. Because it shouldn't reply if the MAC is wrong, because ping only works internally. It does across the internet, but at the end it actually does a unicast request to it. Okay, ARP test, same kind of way. It's looking for a fake MAC address. If it replies with a fake MAC address, you know it could be a sniffer as well, because the sniffer will receive all traffic rather than just the ones destined for itself. Okay. Source routing says add source routing information to a packet. Routers pretty much drop them now. So if it's not being dropped, it could be part of an issue. They're saying it might be a sniffer. Okay. I don't, let's see. I know Walmart and their network in Arkansas, Bentonville, Arkansas, they actually have something to detect this. Because one of the classes I went to, the guy actually did some consulting for Walmart. He says, yeah, they're amazing. He said he was actually teaching their networking people. And during the class, you know, to test their networking people, he would just bring up Wireshark. He said within, you know, a few minutes, they're already on their way down there to get them. So they can detect it. They got something running all the time to look for sniffers. So, pretty good thing. I doubt we'd ever see them here. Okay. All right. Could have a decoy set up in a client or server on the network. Okay. And basically running scripts of doing different things. You know, I don't know. It's just another way of doing it. Okay. They can. Basically, it's fake. I don't know. What about it? Okay, IFconfig. Let me show you a little more about that. I had that up a second ago.
Hey, can you use it in capital X?
I tried it both ways, actually.
Capital X should do it.
Yeah, I did. Come on. Snort dash capital X.
Yep.
No. It's weird. Okay. If I do IFconfig, IFconfig is just like IPconfig. IPconfig is in Windows. IFconfig is for interface configuration. And you can see a lot of information. I already showed you how to do it in the promiscuous mode. You do the interface number like ETH1. And I got that ETH1 from right here, where it says ETH1 or LO. What's LO? Loopback address. Okay. So you can see things in here like with ETH1, I can see my IP address, my broadcast, my subnet mask. I'm running in promiscuous mode right here. I can turn that off by doing right there. Now if I run IFconfig again, you'll now see it's gone. Okay. And does this one support -A? Okay, yeah. Well, same basic output. Okay. But you can see data like how many packets you got going, how many bytes have been transmitted. So you can do quite a bit with it. You can also configure your IP address with it. If you're running a Mac, running Fusion, okay, I think the default addresses for a Mac running a Fusion are 172.16. I'm pretty sure. I don't know if anyone here has played with that. Try running it on the Rose network, because the Rose network is 172.16. So what ends up happening is you bring up your Fusion, and it gives your virtual machines the same IP address of the Rose network, and then you can never get out. You have no internet access. The way to fix it, you have to go in onto the Mac, your Mac machine, and give your Fusion machines a different address. So you can very easily with this. It works the same way on Linux. IFconfig, the Ethernet, you know, ETH1, give it an IP address, and the Mac can change it to 192 or something, and it works fine. Yep, it baffled me for a couple hours the first time. What the heck? It's no internet. I plug in the cable, it worked fine. But when I did the whole wireless, I didn't have internet. So. Alright. Oh, okay. So we saw that. Oh, you can also see what's running. I didn't show you that. And come on. You can also see the stuff that's running. You can actually look and It's kind of like Task Manager in Windows. Some of you hopefully know what Task Manager is in Windows. Okay. If you want here, let me show you what it looks like in Windows. Keep stealing my mouse here. Okay. Here's Task Manager Windows. The same kind of thing you're seeing. Different processes, how much memory they're taking. But over here we get Process ID. In Windows you don't unless you have to specify it. I don't know if you know this, but you can show Process ID in Windows very easily. So you pretty much getting the same readout. Now I'm seeing the Process ID and you can kill processes and stuff like that. So, that's what PSAux does. Okay, saw that already. There's just an output of the command we just saw. Okay, TDR, Time Domain Reflectometer. I think the name is amazing. Okay, it's like our fluke meter. Some of you have seen our fluke meter, I'm assuming, at one point or another. You can actually check the length of cables and stuff like that. And it sends out pulses on the wire. Okay, provides distance information. It says they can detect packet sniffers attached to the network and otherwise silent. I don't know exactly how they can do that, but supposedly they can. Mine doesn't. I bet the more expensive ones do. Okay. Protecting against a sniffer. So if someone's capturing my traffic, what can I do about it? Well, I can use SSL. I can do my banking with SSL. I can encrypt my email. I can use PGP. I can do SSH. There's a lot of different things you can do. Most places now are encrypted anyway, but not all. SSL, Secure Socket Layer, is HTTPS. Anybody know what port that goes on?
443.
Might be good to know for the homework assignment. That come in handy. It's not a question on there, but it might help you still. Okay. 40 or 128-bit encryption works very well. Pretty good privacy PGP made by Phil Zimmerman, correct? Yeah, Phil Zimmerman. Okay, it's actually on version 2, I think now. Excellent tool. If you ever read the book Crypto, it's got a big old deal about PGP in there. Phil Zimmerman's kind of interesting. Okay, we can also encrypt our email with MIME and SMIME. Okay, and SSH, that's the secure alternative to Telnet. Pretty easy to use. You can use scopy to copy stuff, so and it works good. But it's encrypting our data. Okay, I think that's almost done. Okay, there are some ways to protect ARP. You can use static ARP, which means everybody gets a static entry. Very large networks, that can be very tough, but there are some other tools out there. They don't talk about it here, but one of my students, I think it was at the VA hospital, actually uses something there where they can detect ARPs being changed when they shouldn't be changed. I don't know. He's telling me, I just don't remember exactly what it was. Okay? All right. Authentication and naming is another good way of doing it here, and also firewalls. So sniffers are most effective behind a firewall where normal stuff is not there. Okay. All right, that's the end of this chapter. Any questions on your homework on this? Let me continue recording just for a second because I'm going to show you your homework on here. If I can find it. Here it is. Okay. This is I went on to the quiz and I took the quiz and made it into a PDF. So this is the exact way the quiz looks. Don't fill this in and submit this to the Dropbox. Daniel? Jimmy?
Guilty.
Okay. But it says right here, submit the assignments on the quiz page. The below is just so you know what the quiz questions are. I'm not trying to time you on this quiz. I just want them so it can automatically be graded. Okay, these are the 2 packets. There's one of them. I'm asking you all this type of information. This quiz is worth 2 points. Just 2. There's only 2 questions. But it's still, I grade on weight, so really 2 out of 2 is still 100. You know what I mean? But each section in here is worth 10, so you get like 0.9 out of 1 will be a 90. Hopefully y'all can do that basic math. Okay, because Roy was like, only 2 points? Why is it so little? I'm like, it's the same. Okay, but that's what I'm asking you. Based on the above packet, what's the destination MAC, source MAC? What type of packet, and I tell you what sections to get me this out of, because some places the type is listed in 2 different areas. Okay? So I fill all those in. Then question 2, there's another type of packet. You saw this type of packet today. Actually, you saw both type of packets today, I think. Let me look. Yes, you did. You saw both of these packets today. So there you go. Based on the above packet, I got destination MAC, source MAC, packet type, protocol type. sender's IP, and the target IP. Okay? So you should be able to play with it. Easy enough to do with the IP address. Put them in decimal with the periods, like 192.168. For the MAC addresses, colons, spaces, periods, something like that, or nothing. Just easier to type when you put something between them. All the rest of the numbers are in decimal. Don't give me any hex numbers, because it will matter on some of these. Okay? All right. If you got all that, you're free to hit the road. As soon as I can stop this recording. There it is.